What is up, guys? We're back at Qwen-Image again. I just did a video on this where we trained a character LoRA on a 5090, but we're coming back. Why are we coming back? It's important. On that video, we had to do 6-bit quantization to get it to fit on a 5090. That's 32 gigabytes of VRAM. 5090 is the latest and greatest GPU that you can train on right now as far as consumer grade is concerned. We had to quantize it down to 6-bit in order to get it to fit on a 5090. Most people, though, don't have a 5090. The top of the line recently, over the past 2 generations, has been the 3090 and the 4090. And both of these top out at 24 gigs of VRAM. The problem with Qwen-Image, though, is it's 20 billion parameters. Probably a week ago, I added a feature to AI Toolkit so that you can cache the text embeddings, so we can unload the text encoder. That saves some VRAM. But even without the text encoder, which is huge on Qwen, we still are left with the big problem of this is a 20 billion parameter model. If we already did it down to 6-bit, we go any lower, the image is going to get destroyed. It is. I mean, I've tried it at 4-bit. Even at 4-bit, this thing is destroyed. But 4-bit won't train on a 24 gig card either. So that means we need to go down to 3-bit. And that just doesn't work. 3-bit's going to give you pure noise. Unless we use this. So this is something that I trained. It's a combination of a lot of different ideas. So there's something called SVD Quant that they've done it at 4-bit, and then they have the sidechain LoRA. Apple does this on a lot of their on-device models, and they call it an accuracy recovery adapter. I like that name, so I'm running with that name. Accuracy recovery adapters. This is what we're going to use. We can train now on 24 gigs. So consumer grade, 4090, 3090, we can train Qwen, a 20 billion parameter model on this. So here's an example. This is how it works. This is what you can see. So look at this image right here. This is 3-bit. This is what normally happens when you just run it through a 3-bit. So if you train on top of this, it'll actually clean up. But the problem is you're learning how to fix this precision first to get to this image, and then you're teaching it something else. So if you run that on the model, on actual inference, it's going to just be destroyed. So we can't do that. We need it to look like this. This is what happens when you train it at BrainFloat 16. These are your images you get. This is 3-bit, and this is with an accuracy recovery adapter. So how this works is we have another LoRA that sits on the side, and we leave it active the whole time. And when we train this, we actually train it on the model itself. So we'll have one model at BrainFloat 16, which is what these models are run at because they're transformers. So we have one running at BrainFloat 16. We have another model running at 3-bit. And every single one of the weights we quantize, the linear layers, inside the transformer, we're doing a sidechain LoRA. And we train that sidechain LoRA to match the input and output of BFloat 16. So it ends up learning the loss of precision that you're losing in 3-bit because you're not using the full range of BFloat 16. You're only using a partial of that range. So when you quantize it down, you're losing a little bit of precision there, actually quite a bit of precision at 3-bit. But so this accuracy recovery adapter is a small 16-dimension LoRA that I trained on top of it that tries to recover the loss of accuracy across each layer. And when it does that, it actually works surprisingly well. I couldn't believe how well it works. Like you look at this image compared to this one. Wish I could zoom out a little bit here. No, I just can't. Okay. But you look at the amount of accuracy you're losing here. I mean, it's not a perfect 1-for-1, but I mean, look at this one. This one's a long prompt. And it has, holding a DVD. This is a test. There's bear in the background dancing with the giant, mushroom man, cat, orange tabby, black cat, split down the middle, having a pink thing. I mean, it's an enormous prompt that I use as a test. 3-bit destroys it, but you come back and it has all of this. I mean, some of it, like the DVD, it's a little different, but for the most part, it's accurate. It has all the stuff in here. It doesn't have these noise artifacts from loss of precision. Anyway, this is called an accuracy recovery adapter. And this can be trained for every single model, just has to be trained for it. It takes about, an hour or 2. You used to have a GPU with enough VRAM. Really easy to train. You can read more about that here. I'll post links. You don't have to worry about this though. It's going to auto download it. So let's get started. I'm not going to go over how to install everything, but just go to the AI Toolkit repo. You can come down here and it kind of shows you how to run the UI, how to install. So this should get you installed. I already have it installed on my local system. Normally I run it on Cloud Compute for this, but since this demo, this is running it at home. This is running it on a 4090 at home on your own computer. That's what I'm going to do today. So on my computer, I actually have a 5090 and I have a 4090. The 5090 is running some other stuff. We won't worry about that for now. We're going to focus on my 4090. Let's head over to the data sets. Let's do a new data set. So today we're going to do medieval art. Let's drop in. I got 40 images, actually I think 39 images roughly, that I went and grabbed from various places on the internet. These are all medieval art. So we're going to caption these, and I'm going to go over how to caption them, in my opinion, the best way. Let me go ahead and get them captioned first, and then we'll revisit. All right, we have all these captioned. Let me go through some of the captions and how I'm captioning. So for style, some people like to have a trigger word for style, so they could just call it like talk style or whatever. Some people like to actually name it what it is. So in this, we'd do medieval art. And the way I like to do it personally is I want to train the model so that everything it sees, it's just normalized, right? So I don't want to caption any of this I don't want to say that it's medieval art. I don't want to say that it's drawings. I don't want to say it's on paper. I want to caption it as if it's an actual photo of these people doing whatever it is. And this is up to your own personal preference. I like this way. That way you don't rely on a trigger word. You're just going to burn into the model. Hey, this is normal. This is just normal. Someone types in anything, type in an angel, this is what you get. You type in a face of a man, this is what you get. That's how I like to do it. Do it however you like. For my captions, I'm just going through, and I don't want to do much. I find with style, less is more. So if you come in and you label, there's blue outline, and then inside that there's a D, and inside the D there's a man, and he's got a blue robe on. He's also wearing an orange shawl with a bell on it. If you describe everything, it's not going to learn all the style, because a lot of those description factors, a lot of the stuff going on in the image is the style of this medieval style. So I'm going to ignore it. The only thing we want to caption is what makes this image in our style different. So I want all of these like little designs inside the D, all this, the clothing, etc. So I'm just putting the face of a man. On the text, if it's legible, if it's not in Greek, Hebrew, whatever that is, I want to say it. So this says the devil. So I'm just doing a picture of the devil. I'm not putting it has a face of a woman, tail of a snake, or snake tail. I'm not putting any of that stuff. So that's it. We have 39 images. You can probably get by with less. And doing too many, I think it doesn't learn as well. This may be on the high side. I find about 20 images or so is probably a good balance. I'm doing a little extra. One problem with stuff like this is you'll start seeing this demon face in everything. If you only have like 4 images, it'll learn this or it'll learn this, and it'll start putting it in everything. So the more you have to break it up, it works a little better, especially when you have like these very unique looking characters, just to kind of show it there's a variety. So let's pop on over to new job. We're going to name this one Medieval Art Qwen. One of the most important things is we have to actually select the Qwen model if we want to train the Qwen model. Here's where it gets cool. When you click on this, we now have a few different options. And this is only on some models. I'll add more accuracy adapters. But for now, accuracy recovery adapters. For now, it works on Qwen-Image. So you can see 3-bit here. If you do the normal 3-bit, it's going to be broken. And that's a good experiment to see how broken it is without the ARA. Text encoder, we're going to leave at float 8. That's the default, because we're going to come over here and cache text embeddings. So we're going to unload that text encoder completely. It won't matter. Linear rank, let's do 16. One, for VRAM savings. Two, this is a 20 billion parameter model. Doing a high rank, like even this is going to be like 250 megabytes. You don't really need to go much higher than that unless you're doing a huge fine tune or a big LoRa. I'm going to leave this all on weighted. This is good for styles. Sometimes we may have to switch this later. I'm going to leave it on balanced time step bias. So this is what part of these time steps it's going to have a bias towards. We might want to do high noise since we're changing so much of the image, but I'm going to leave it on balanced. Cache text embeddings, very important. You can read how it works here. We have to do that to get it to fit on 24 gigs of VRAM. Other than that, we're leaving that all the same. We can do it at 1024. It'll train at 1024 on a 4090, or it should. If you're getting or you're running out of memory, just go ahead and do it like this. This is fine. This is going to work fine. You don't need that super high resolution to train a little LoRa. But I'm going to leave it on here just to show you guys that it can work at 1024. We have our data set, medieval art, selected. I'm going to go through and change some of these captions real quick, and we'll kind of go over them because I want to do medieval memes. I think those are really funny. All right, I put together some prompts for us. These ones I'm kind of going for like this whole medieval meme style thing that got kind of popular. I love it. It's hilarious. So we have a woman kneeling in front of a cat with text that says, "What is thy bidding, my master?" A band playing instruments with text that says, "Medieval metal men." A crazy scientist performing an experiment with an explosion. Text says, "Thou mixest thy wrong shizzle." A man pointing at his hand with text that says, "Giveth to me." A man counting a huge stack of money with text that says, "Counteth thy dollar bills." A woman doing a trust fall and falling to the ground because the other people are distracted and talking. The text says, "Don't thou trusteth thy team." I cannot read this. An astronaut on the moon riding a horse with text that reads, "It maketh no sense." Photo of a man. Oh, I didn't do this one. Skip through that one. A cat sharpening its claws with text that reads, "Thou disappointeth me." A man and woman walking down the street. A man is looking back towards the camera at another woman closer to the camera. His girlfriend is angry. So this is like that distracted boyfriend meme, basically. A woman shushing a man. She is pinching his mouth closed and holding her finger up to her mouth. Text says, "Shutteth thy mouth." I don't know how these are going to turn out. They may not turn out good. They may turn out great. But we got them together. That's it. So recap, I changed all these. You can put them however you want, or you can leave the defaults. That's up to you. We're leaving it at 1024. We're doing medieval art. We're going to do it for 3,000 steps. We're going to leave learning rate, time step type, time step bias. We're going to leave all that alone. Cache text embeddings. We're going to do low VRAM, Qwen-Image, 3-bit with ARA, LoRa, 16 linear rank. That's it. We click create job. This is training locally. I have my GPUs undervolted a little bit. I think they're still undervolted. So you might get a little better performance here. We are on RTX 490. Everything's good. Local run. Click play. You can see here it automatically grabs the LoRa from the hub. Accuracy recovery adapters. I'll put links in the description so you can see all this. But if it already has it, it'll always say it's grabbing it. It detects it locally though because it's cached. So it'll just pull the one locally, but it'll download it the first time automatically. What the quantization's doing right now is it's going through and finding all the layers that we have inside our LoRa, and it's just quantizing those layers because we don't want to quantize to 3-bit a layer that we don't have an adapter for. So if there's any other parameters or weights inside there that aren't a linear or convolutional layer, we don't want to quantize those because we don't have an adapter. So this is just going to quantize all those individual layers, and it's keeping the VRAM low because it's just doing one layer to the GPU at a time. Now it's caching the text embeddings, so memory's still staying low. It's about 12 gigabytes. All right, that's it. Happens real quick, caches all the text embeddings. We have about 4 samples done. It is kind of slow. On a 4090, I'm getting about 89.12 seconds for an image. And a lot of that's because, the high quantization. I'm still working on getting that where it's faster. But you can take a look at our VRAM. We're only running less than 20 gigabytes of VRAM to generate these samples, which is crazy for a 20 billion parameter model generating at 1 megapixel. The samples are generated. These are the initial samples before any training. Let's take a look at this VRAM though. So we're at step 9, 11 now. 23 gigabytes of VRAM. Amazing. 20 billion parameter model training at 1 megapixel images. Incredible. So let's go to samples. Take a look at these one at a time. What is thy bidding, my master? This is a ChatGPT image for sure. Their data set is just loaded with it. I would guess probably 50%. Medieval metalman. Thou mixeth the wrong shizzle, giveth to me. Now, I am wondering, this hand, you may not notice this, but this is not a normal looking hand. But I am wondering how the BrainFloat 16 version would compare to the 3-bit. I mean, in my experience, it was just small details that are different. The overall composition was the same. I imagine it still does this weird hand with that. Counteth thy dollar bills, don't thou trusteth thy team. I cannot speak in old English like this. It maketh no sense. Thou disappointeth me. This is supposed to be the distracted boyfriend meme. Shutteth thy mouth. I don't know why he has cat whiskers. I guess he's getting shushed. I don't know. But these are our baseline samples before any training's done, so we know this is what the model's current knowledge is. If we typed in medieval meme or medieval style, it may actually know a little bit on that. But we're training it, so this is going to be its baseline. Instead of its baseline looking like a ChatGPT image, hopefully it's going to look like our medieval memes. So let's wait for the next samples and we'll circle back. We have our first samples in. Let's take a look. Not a lot of change happening. Let's see. So this one goes from there to there. There's some, it is learning. I think it's a little slow though. Kind of seems to be going to our direction, but it's not going fast enough. So I'm going to go ahead and stop this. We can just hit the pause button. Remember, you can stop and restart at any time. It will only restart from your latest checkpoint though, so just keep that in mind. Okay, we're stopped and we can edit. So let's edit. We can either bump the learning rate. I'm going to go ahead and do that. So we'll go to 2e-4. We can change this from weighted. We could actually do shift. That might be better. I'm going to leave it on weighted. We could also change the time step bias to high noise. That'll make it focus on more of the composition of the image. I'm not going to do that right now, though. We might come back and do that. Right now, I think bumping the learning rate up to 2e-4 is good. I would never recommend going above 4e-4. I've had models break down a lot at 4 and higher, so we'll leave it here. The rest of this should be fine. We'll just update the job. This will speed it up a little bit. Restart it. Okay, we got our next samples in. Let's see. Okay, we're getting movement. Thank goodness. Let's take a look at these. Yeah, we're starting to get it. What is thy bidding, my master? It's looking good. Still kind of have the GPT orange. We can start calling that. But although these kind of have an orange tint anyway, but even with their orange tint, they're not as orange as the ChatGPT orange. But yeah, this is coming in good. Thou mixest the wrong shizzle. Okay. It's not great, but it's going in the right direction. I thought I did this where he's pointing at his hand. I don't know. I'm dyslexic, so I probably typed something wrong. I do that a lot. You guys have probably noticed. Counteth thy dollar bills. These are looking good. I'm really liking the direction it's going. Goes from that to that. Okay, so obviously it still needs a little work. Oh, perfect. Thou disappointeth me. Okay. This one's not doing much. It's starting to break though. That's good. Shutteth thy mouth. Perfect. Okay. So we'll let these run on out. We'll probably let it run out to 3,000 steps and revisit. We are at 3,000 steps. Training has stopped. We are done. check out these samples. All right, so just from a high level view, it looks like it worked. Let's see it, the last ones. Okay, some of the, you can see it, like, what is thy bidding, my master? A little bit of the text. Let's see if we go up. The text is a little cleaner the higher you go up. But that's fine. We can always lower the LoRA rate, the LoRA strength if we need to. So this one is Medieval Metalman. Text is not perfect at the end, but man, I'm loving it. It's so great. Thou mixest the wrong shizzle. That one's great. Just a big finger giveth to me. Oh yeah, I forgot. That's one thing, is a lot of our data set has it where the text is just kind of on the screen. But yeah, it says giveth to me. So I guess this is all the same one here. Pointing at his hand. Of course, you know, came from this. So pretty good. Counteth thy dollar bills. That one's great. Don't thou trusteth thy team? So see how like the text is up above it? Anyway, that's great. It maketh no sense. Man, I love all these. Thou disappointeth me. I don't remember what the text was on this one. But yeah, it looks like it was struggling. We go up. It struggled to break free on that one. This is a longer prompt. Longer prompts tend to have more issues. That's just the way LoRa's work. Shutteth thy mouth. Oh yeah, all these are great going into it. I love it. All right, I'm going to download this up. I'm going to get it loaded in the Comfy. Let's test it out. We got the LoRa loaded in. You can see right here, Qwen-Image, Medieval Art, Qwen Safe Tensors. We're using the FP8 version of Qwen-Image, or at least the weights. We are loading up. We have the text encoder. We have the VEI. We're using Euler Simple, 30 steps, CFG 2.5, C to 42 fixed. 1024, 1024. Those are all the things. 310. I guess I can just read every single thing on the page if we need to. But I will read this, the most important part. A scientist messing with a supercomputer. Text says, you traineth this LoRa with Ostrus AI Toolkit. I don't know if it's going to run. Let's see. Oh my God. That's amazing. It's so good. Okay, so that is how we can train a Qwen-Image LoRa on 24 gigabytes of VRAM. I did not think I was going to ever be able to say those words. I thought we couldn't train Flux at 24 gigs of VRAM when it came out. This model's almost twice as big, and we can still train this. So I don't know, maybe we can train a 100 billion parameter model on 24 one day. Who knows? But hey guys, if you find this helpful, you find AI Toolkit helpful, you find this accuracy recovery adapter helpful, training Qwen-Image on 24 gigs of VRAM helpful, please be sure to like and subscribe to this video. That really helps out the channel a lot. But if you really want to support me, you can go check out ostrus.com support. Here you can see how you can support me on Patreon, GitHub sponsors, PayPal, and you can also look at all these amazing people that currently support my work on a financial level. Without all of these amazing people, none of this would be possible. So I want to say thank you to all of my supporters, and thank you for all the people that follow me on YouTube. I'll talk to you guys next time.